Now I would like to pass the presentation to Holger. Let me share here. This was the agenda for today. We have the last session, which is from Holger, from doctor in engineering. It's not Holger, just Holger. It's doctor in engineering Holger Friedrich, and he's going to talk about and do some demos also that will be very, very interesting about autonomous data warehouse, cloud, and Snowflake, which is more suitable for analytics. So this is a great comparison. Holger.
Hi, Edel. Thank you for introducing me. I hope you all hear me well, and I'm trying to grab the screen now. Let's see, and there we go. Now you should see that, and I'm going to.
We see your screen, man. Yes.
Yeah, see my screen. That's of course very good. I hope you still see it.
Yes.
And I hope everything will work well when I change the slides and go from demo to demo. Okay. Yeah, thank you for having me. I'd like to talk a little bit about autonomous data warehouse and Snowflake and discuss the question from an analytics point of view, which one might be more suitable for analytics. Well, of course, this is a little bit provocative, right? So the answer is, I'm also a consultant. I can already tell you, which is, it depends, right? But yeah, we'll see which one might be better suited for more general and more specific, and which one for more specific workloads. So let's go. First, a little introduction, then we'll have a look at the contestants and what's their characteristic architectures are. We'll compare them with respect to a few criteria, and we'll come to a few conclusions. Okay, so let's go. First of all, yeah, some of you know me already, others don't. I'm from a Swiss long-time Oracle partner who is really focused on warehousing, big data, BI analytics, and data integration topics. And we've been doing that for more than 20 years now with Oracle on premises. And we're also doing it with Oracle in the cloud. And for customers that are not heading into the Oracle cloud, and as you all know, there are quite a few, we also added Snowflake to our portfolio already a few years back. And so that we can basically have solutions for everybody. Okay, myself, as Edel said, I have a doctoral degree in engineering and a diploma or master's degree in computer science, specialized at the time in robotics and machine learning. But since also more than 20 years, I'm basically in this area of warehousing, data integration, machine learning, BI analytics, and been an Oracle ace for more than 10 years, I guess now. But that's enough for me. Let's go to the topic at hand. So, I mean, first of all, we're talking about cloud warehouses today, not on premises. So when I talk about Oracle, please forget the on-premises Oracle world, right? We're talking about the cloud world. Might not be a big thing for our American friends who are listening in, but at least in Europe, and especially in the German-speaking part of Europe and in Switzerland, the movement to the cloud is very slow, right? So many people, when they think of Oracle, still think of on-premises. But we're talking about the cloud, and then we are talking about thinking about the promises that the cloud gives us, like everything is cheap, simple, you can be agile, you can scale. Well, however large or small, you need to be all that with great performance, loads of features that are easy to access, and the data is easy and secure to access. And that's the general cloud story, right? But now when we look at analytics in particular, I mean, what do we need lots of stuff, but among these, we need connectivity to the engines that we use. From our tool set, we need often enough some business dimensions, some dimensional structures. So these things, not just raw data and raw tables and stuff, we need metadata with all of that. Of course, we need great scan performance if we want to aggregate KPIs, well, scan lots of data and then aggregation performance to aggregate KPIs. Sometimes we got so much even in the cloud that we need to pre-aggregate it, or there is a need or a use case for pre-aggregations. Of course, everything has to be very secure. Yeah, but also we just reading some star schemas, that's not what we do today anymore only. We also want to be able to analyze semi-structured data, to do some graph analysis. So advanced functionality, add machine learning scores to our dashboards and reports, all of that. And yeah, scalability, of course, that's always an issue in BI, right? So that's what we want to do. Now let's have a look at our contestants, because they are pretty, although they offer similar things, they have very different architectures underneath. So if I'm calling this Snowflake at a glance, right? I don't know how many of you are familiar with Snowflake as an engine and the architecture below. Therefore, let's just have a quick look at it, because it's very different from an Oracle, from an old school Oracle or SQL Server or DB2 or whatever engine. So the characteristics of Snowflake is that it's basically these three layers, where the storage is centralized, and the storage is basically the object store of the cloud provider. So it's S3 for Amazon, blob storage for Azure, or the Google object store. And that's where our data files lay, right? On top of that, there is this blue compute layer. That's the customer's compute, where we can have arbitrary many compute nodes. Of course, we have to pay for them when they are running, but we can configure them in size according to the typical cloud providers' regular shapes, mostly in powers of 2 regarding the compute power, and we can destroy them and build them quickly. And on top of that, there's the service layer of Snowflake, where they hold all the metadata. So there's big difference when we compare that to an Oracle database, right? So we have the storage, which is on an immutable storage. So they cannot update their database files, which basically means whenever you update something, and just being it one record, and that has to be written down, they are going to write a large chunk of a database file anew. On the other hand, of course, it's much easier for them to write and to update stuff, because they don't need this very complex undo whatever mechanisms that Oracle has, right? On the other hand, a very positive thing is that the service layer contains all the metadata. So you can with one user, you can basically use many compute nodes of many different databases. And one compute node can use many different databases. So it's very flexible. So the whole thing is really a fresh start for data warehousing and analytics-focused relational database management systems. So this is already pretty different, even though it's the same, more or less the same SQL API in the end. Now, when we look at the Oracle database, this is more or less in the middle. We see just in central, this is more or less the same old Oracle database that we know, with all its options and possibilities and stuff, just extended by automation around it, and fully managed by Oracle in the Oracle Cloud, which is the only platform, as we know, unfortunately, until now, where we can use it, where we can use that service. But the interesting thing is this whole zoo of tools and tooling that Oracle built around it, right? So it's not only that the database has lots of engines in itself and is really mature, but now they built all those cloud services around and deeply integrate them. So that's pretty different from the architecture of the system, right? So it's automatic and extended, a well-known platform. So now, how do these perform for analytics? Let's look first, quick look at the strategy of the companies behind it. So we have Oracle, which apparently had the market leading on-premises RDBMS, and then the cloud came along. And then they basically said, okay, we're going to automate that in our data centers. So we fully automate it, and we have it also we have it in our cloud data centers and for our on-prem cloud solution, cloud customer, with the same options and everything. We're not going to strip it down significantly. And then now they say, well, this is a data platform. Everybody has now a data platform. It's not only a database, it's a data platform with all of that tooling around. And Oracle spends lots of money and time on seamlessly integrating it with other OCI services, which is of course great if you're in the Oracle Cloud anyways, and you use other services. You have a very, very, very good and deep integration between the different things. Snowflake, on the other side, being founded by ex-Oracle guys, started off as a multi-cloud data warehouse solution. That was the first offering, right? And then they added on top of that the data sharing feature, which basically means that you can, due to that central service layer, you can sort of provide read grants to other people, other accounts, even other customers pretty quickly, because it's just metadata operations, basically. Something that is pretty hard for Oracle to do, since there the metadata lies in each database separately, more or less. And then they thought about monetizing that and giving the customers the chance to monetize that by adding this data marketplace feature on top. And now, since the arrival of Mr. Slotman, the acting CEO, who also was the CEO during the IPO, Snowflake claims that they are now the best platform for data applications. That I find a little over the top, and we will see why. Maybe they go there, but we don't know. And if you look at the bottom at this picture, you see those 6 icons. And when we think about what can they do, where are they coming from, and what can they do very well? Data warehouse, data lake, yeah, they are very good at that. Data sharing, they're also very good at that. But data science, for example, Snowflake does not offer something like machine learning algorithms inside the engine, right? Snowflake is a great big bucket for machine learners that run Spark clusters or program Python outside of it. But they are not running machine learning inside the database as of yet. So there we have to maybe take the marketing messages with a little grain of salt. Yeah, but now let's see, let's compare. And what are interesting criteria to compare, and we'll see how much time we have to go through these. Some we'll talk about, others maybe just quickly. And I thought, well, those are 8 criteria. Well, modeling capabilities. What can we model in the 2 platforms? How can we use it? What kind of advanced SQL constructs do they support, the SQL engine? So basically the maturity of the SQL engines. Do we need and are we able to apply tuning to our data? Because we have this typical, for me, it's a typical cloud pattern, is that you get a very, very highly automated and easy to use service where you basically have very little control, which for some use cases and for some users is great. But if you are on a budget, and in a company, everybody is on a budget, might be small, might be large, but you have a specific budget, then you might have the need to tune, to be able to tune, because you need to get more, more bang for the buck, basically. And many of these cloud services basically just tell you, well, if you need more power, just put in more money into the slot. So this is important. Security, okay. Diverse workloads, I've been already mentioning that, the ability to have large data sets that are analyzed, but also find small data sets, like an application workload where you might find small data number of records inside large tables quickly. How performant are they? Then the question is beyond SQL. I said, okay, today we not only want to do SQL, we also might want to do spatial analysis or analyze social networks via graph analysis, these kinds of things. And in the end, ease of use. So how simple are those things to use? So let's dive into that. First, modeling. And there, I mean, yeah, if you look at it, usually in a relational database management systems, our data sits in relations, in tables, okay? But yeah, for analytics, we want usually more. It's nice to have metadata associated to the real data. So when we look at the autonomous data warehouse, since it's an Oracle database, we have our tables, but then we can also add metadata to them. Which are facts? Which are dimensions? What hierarchies are in these dimensions? What attributes belong to different levels of a hierarchy and stuff? We can even build analytic views these days that combine all this together in one metadata object. And if we need pre-aggregations, we have very complex and, rich mechanism and powerful mechanism to pre-aggregate stuff and keep those pre-aggregations most current with materialized views. When we look on the Snowflake side, there's nothing of this metadata-driven stuff. There are materialized views, which nowadays can contain joins. Up until 2 years ago, they wouldn't even be contain joins, right? So apparently, Snowflake is, as of now, pretty limited regarding modeling for analytics, I would say. Of course, they are catching up with all of these things. Let's have a quick demo. I hope this is working. Please cry out if you don't see if you don't see the screen. Just a second. This is nice now. I have to make this a little differently. Otherwise, the Zoom bar is doesn't let me see my tabs. Okay, so when we look at Snowflake, this is the Snowflake has currently 2 web front ends. That's basically their 2 front ends. And if you look on the left side here, I hope you see.
I believe we're still seeing your slide that says.
That's what I thought. That's, yeah, okay, not a problem. I have to basically, I have to exit, I think, the presentation mode. I hope now you are, let me see, you should now, yeah. Now, are you seeing the Chrome now?
No, not yet.
Not yet. I'm seeing your PowerPoint. It looks like you're in PowerPoint mode.
Yeah, then I have to manually go to the other thing, and we have to go back and forth. That's okay. So, but now you should see it, right?
Yes. Yes.
Yep.
Okay, great. So we'll do that back and forth. Thank you for interrupting me. So when we look, this is Snowflake, the old Snowflake front end, and there we see basically that's a demo schema from them. And there we see how they would do a star schema. So it's basically just tables, right? You've got orders, you've got customers, and you can look into them. That's standard stuff, but there's no metadata attached to that, okay? And now let's compare that with Oracle. Now this is the data catalog feature. If you go to the database actions in the Oracle Cloud interface, you can go to the catalog, and then then you end up here, right? Okay, and here we see tables. And this is, of course, again, this is this SSB example schema. You have line orders and you have 4 dimensions around it: parts, suppliers, customers, and date. But now, of course, here we have, for example, hierarchies that we can define on those. And we see here hierarchies that are defined on those. And we can define analytic views. So we have these metadata objects in the autonomous data warehouse, okay? And we can also go in here and have a look at it. Now we'll get a little error message because they are not finished with this, I guess, really. But now we see here our analytic view with those 4 dimensions, hierarchies, and all our KPIs, and we can see that from the line order, we get those KPIs. So this is much better for modeling things and understanding things also when you are coming from an analytics point of view. And we can basically go and query those as we like. So now I'm changing over to the SQL action, and when I look, this would be a query like it was in Snowflake, right? I'm writing a select and then I'm joining those tables together and have some filter and join conditions and stuff. Now, if I use the analytic view with all the metadata, the query looks pretty different because I'm just querying this analytic view, telling him along which hierarchies I want to query and give some filter conditions. And I don't have to write joins and these things because that's all in the metadata of the view. And when I run it, I can go to my performance hub of my database, and I think I need a little bit of refresh time here. Now what's happening? Of course, it's already there. It's been in the result cache from an earlier execution. So we just changed something, and hopefully it's not in the result cache anymore. Well, it is. I've been playing around too much with this. Yeah. So, but it's mighty fast, and you can see that when we look at the explain plan for this, you can also see that it's basically doing all of these joins. Yeah, the hash joins, and it does all of that stuff. Okay, so let's move back to the presentation. Sharing the screen again. That's that. And play. Okay, so what we've seen is that the autonomous data warehouse is much more mature regarding these things, all the analytics related metadata. Plus then we haven't seen that the integration with OAC and OAS, you can really just take these analytic views, build an RPD from them without having much work to do, and upload that into OAC and use these things to their full extent. Now let's look at the advanced SQL part. There, I have to say, Snowflake has been catching up pretty much. So if you see Autonomous Data Warehouse has these rich analytic SQL capabilities and the query pattern matching clause since a few years. And Snowflake started off with some pretty good analytic SQL capabilities also. And they added query pattern matching this year, right? So they didn't have that before, but in 2021, they added query pattern matching. So what they are missing is the model clause that the Autonomous Data Warehouse has, but yeah, let's be honest, who is using the model clause? I always say for 99% of the users, the model clause is too complicated to really get their head around, wrap their head around, plus there are not that many use cases. So regarding this, the advanced SQL capabilities, I think they are both very, very mature. Much better than the other platforms one might look at, like Synapse or BigQuery or things like that. Okay, another thing is tuning. And I've already been talking about it, that you might want to be able to tune stuff, right? Because you have a limited budget, and just adding more CPU to your virtual warehouse in Snowflake or to your ADW instance might not be a strategy that you can follow just for financial reasons. Plus, some stuff is growing exponentially, so you might want to do different things. And of course, Autonomous Data Warehouse, it's an Oracle database. It has great analysis capabilities. Explain plans. We can even trace stuff also in ADW. And we have the real-time monitoring in the performance hub that we already saw. And we can tune. We can index like on premises. We can use hints still. We can use SQL plan management. We can really tune the stuff and get the most out of our investment. Snowflake has this cloud service follows this cloud service paradigm from the beginning. So you shouldn't be able, you shouldn't have to do lots of stuff, right? So for analysis, they have explain plans, and we'll see them in a minute. And they have some high-level monitoring, but it's not comparable to the performance hub in ADW. For tuning, there's really not that much that you can do. You can cluster your data on the storage level, such that Snowflake is basically using something like ADW uses with on Exadata with the hybrid columnar compression, storing columnar data in chunks of a few megabytes, and that's what basically Snowflake does too. And you can cluster the data along some attributes such that most of it is really clustered in chunks, in micro partitions, as they call them. So that's a sort of a tuning, but it's on the storage level. And the other tuning thing that they have is the search optimization service. And we'll have a look at that now. So, but before the demo, I would say Oracle gives us lots of control and has lots of capabilities. So we are able to get most bang for the buck from them. Right? With Snowflake, we have our control is very, very limited. There's not much that we can do. And so basically we have to tune by altering our model, going to the storage layer with this clustering, or basically paying more. That's the point. And now let's have a quick demo for this too. I'm going to share my screen again over to the Chrome. There we are. Hope you see it. And now yes. we want to go to this screen. This is the newer Snowsite, the new SQL or development environment of Snowflake. This is I think in public beta basically since a year or something. And so there's stuff that is in the old GUI, and there's stuff that's in the new GUI, but I don't know at what point they really want to switch. Now, what I did here is I generated a table, making this a bit larger, generated a table of 1 billion rows with some data in it. And what I wanted to show you basically, let's go there first. What happens when you query this table of 1 billion rows with a query where you just want one value? And this is not a unique column, but there's just in this billion rows, there might be 100 rows or something with that value, with that filter value. Okay, so it's, and that's of course in the Oracle world, that's a great thing for indexes. Now Snowflake doesn't have the concept of an index like Oracle or a SQL Server or stuff. Right? This is, by the way, why you don't have primary keys and unique keys in Snowflake, where you can define them, but they're not going to be enforced because they don't have the concept of a unique index that is synchronously managed. So if you build a 1 billion row table and you run a query with a highly selective column with one value, we can see here in the overview what it did. It read 72 gigabytes of data. That's the micro partitions. It had to scan basically almost all micro partitions for that. And it took 1:40. Now, if now Snowflake says we are doing data applications, which also means you might have 10 billion rows and you only want 3 of them, then every time waiting minutes for that result and also producing lots of CPU and IO costs is not what you want. And that is why they basically, I would say, sort of reinvented the concept of an index, only they are calling it the search optimization service. So what I did was I created the same table with a different name, and I said, add search optimization to that table. So that's their thing. It's a service. You say, I want to add the search capabilities, basically sort of an indexing, but it's not documented publicly what it really does. I think it's single column indexes, I guess, to a table. And then you can, excuse me, I have to get to this play button here. And then you can see how far, when you look at this show tables query, you can see going back here, the progress, because that's asynchronously done. So it's not blocking but you might benefit a few minutes later. So it takes a few minutes for those 1 billion rows, and then it's with 100% and everything is fine, right? And now when we do an explain plan of this table, we get an access through this search optimization access, right? Very interesting is how much did it cost? You can basically look for each table and how much did it cost to build these indexes. When I do that, I see I built them one time and then it was maintained and it cost a credit. Yeah, but that can take, if you have lots of columns on that table, it can take lots of credits, right? To get this thing. So basically, if somebody says a Snowflake is very, very cheap, that might be also because they don't have indexes and primary keys and stuff. As soon as you build these things, it gets more expensive because you need more CPU to manage all of that. Okay, and then if you run this if you run this query, and I did that already, against the search optimization service, as we see here, it only takes now 4 seconds. This was including compile time on 1 billion rows, 4 seconds. Yeah, and it only had to read 1.2 gigabytes of data instead of the 73 gigabytes. So basically, it's what indexes do, right? But for Snowflake, that's a new thing, and that's all they can do. No hints, no specific multi-column indexes, these kinds of things. So you have to know what you need, right? If you're let me see, sharing this. If your use cases are fine with these things, then yeah, then everything's great. So do you see the slides again, Edel? Oh no, I guess
yes,
you don't.
Yes, I can see that. Yes.
You see the slides? Okay, then we go back.
Yes.
This is really this great Zoom world with demos. Okay, so we've seen that basically now that we have regarding tuning and making the best out of your budget. The autonomous data warehouse gives you much more options. But then again, if Snowflake is out of the box fast enough for you and everything, then you don't need it, okay? Okay, security, they are sort of also now on even ground, because Snowflake in the last 1.5 years added column and row level security to the product. Like the Oracle database had VPD row level security for a long time, and data redaction also since some time. You can encrypt, the data is encrypted. You can use customer owned keys for doing that. With Snowflake, that's an additional, that's a different edition of Snowflake that costs more money. But with Oracle, yeah, if you need key safes and all of this kind of stuff, and that's also costing money. The only thing that Oracle here still has, well, as an addition, is the data vault option. Not the modeling, but the data vault option that we know from the database to basically hide data from the administrator's eyes. But both platforms are very secure. Now, diverse workloads, we already saw that now, that, I mean, Oracle is an OLTP and a data warehouse database. It always did both, and it still does both. We got storage indexes and chunks of hybrid columnar compressed data because it runs on Exadata. We can partition, we can index, and we can, with ADW, that's on top of all of that, that we know, we have the automatic indexing feature, which tries to, or which infers indexes from workloads. Which is, I think, more sophisticated than the search optimization service at Snowflake. And since 2 or 3 months, we also have automatic partitioning, where Oracle basically infers partitioning from the workloads and tries to automatically partition the data right, or in the best way for your workloads. But of course, this is also CPU that you have to pay. These services cost CPU, okay, and you're going to pay that. Whereas Snowflake has their storage indexes on their micro partitions in the storage layer. That's pretty comparable. And they have an automatic clustering feature where they shuffle the data around based on the workloads. That's a little bit like the automatic partitioning. And they have the search optimization service building these asynchronous indexes. So Oracle is a proven market leader for diverse workloads. Snowflake, in my opinion, oversells on their application workload capabilities, not only because of these performance features, but primarily because who wants to run an OLTP application without a primary key on tables that is enforced? I mean, I think there is things that they got to do. Performance. Yeah, I'll just let that stand here. There's lots of performance features. You get the slides. You can see that all of those performance features that both of them have. Snowflake is incredibly fast in scanning stuff once stuff is on the local cache. Basically, what Snowflake does is they are running standard compute shapes in the respective cloud they're running on, and they run them with lots of local SSD disk space and quite aggressive RAM. And so once the data was read to the virtual warehouse, to the compute node, things are pretty fast there, right? So the first query might be slow, and then when the warehouse is warmed up, the rest is pretty fast. Yeah, but if you need more performance, you have two ways you can get it. You can scale up, which basically means in the background they are starting a new compute shape which is twice as large, or you can scale out, basically more shapes. But if you in parallel, but if you scale out, be aware that your queries don't fan out over more than one shape. So basically, it's like if you're in a rack environment and you say local node only. Okay, so if you need queries with higher parallelity, degree of parallelism, you scale up. If you have more queries for a certain degree of parallelism, you scale out. Okay, whereas the autonomous data warehouse, that's a rack. You might have one or more nodes depending on the CPUs that you are using, and it's scaling seamlessly using the resource manager. So you can scale up one OCPU or down, and you don't have to go in the powers of two, which might make a difference in cost. All right. Okay. Now, beyond SQL, when we look at the autonomous data warehouse, it's an Oracle database. It has all these options, right? It has an entire, really very mature programming environment with PL SQL, and you can program Java in it. At least I don't know what the ADW, I don't know about the Java capabilities really. But you have the machine learning option, spatial option, graph. You can have a very mature XML database in there, text text handling and analysis, and those great JSON capabilities that Peter Hammerschmidt and his colleagues implemented in the autonomous data warehouse in the recent years. And there on the Snowflake side, you see they're really coming from being a SQL engine. So they have a very good SQL engine. We established that. There is a little bit of XML that you can do, not very sophisticated. There is some JSON that you can do, JSON analysis and generation of JSON. And they added a little bit of spatial functionality. So they have some spatial data types, and they have some spatial algorithms implemented for distance computation and these kinds of things. But it's not comparable to the spatial functionality that the autonomous data warehouse has. And then they have JavaScript programming environments, which is, well, I think some rudimentary, really, compared to a PL SQL environment. And everything else that they are doing now, or that they are having with their Snowpark or feature, where they want to add basically, well, where they will at one point in time have Python classes that provide data frames to Python. Now they have it in public beta, I think, for Scala, such that you can use data frames in those languages in your applications, but the data is really, well, stays in Snowflake. But this is basically, for me, that's the future. That's not what we have now. What we have now is what you see on the slide. Right, so basically Oracle is the full converged database with multiple engines, while Snowflake focuses up until now on data management and nice APIs to files and data that they have in their belly, basically. But yeah, but those other engines and stuff, that's a little, they're growing there, but it's not there yet. Let's have a quick demo on that. The last demo. That's basically back to Chrome. And that's another demo for Oracle. And this is the Graph Studio. So that's something that you don't get from Snowflake, but that you have in Oracle, that you can basically go to the autonomous data warehouse and from the login page say, I want to go to the graph. And here you can basically model, and we have a model here, this sales history model that I made, and we have a graph, which basically is a translation of the sales history model that we all know, the example database, to a graph representing these the dimensions and the sales data. And then you can have notebooks here, which are Zeppelin notebooks, where you can really interactively analyze, write code and analyze that stuff. And if we, well, I'm just going there to this little basic one that I did. That comes with Oracle, and I added myself as a person here. This is all persons and places, and who knows who is connected to who works where, and then you can basically run this. This is now building this graph from these commands, but I could also just load, for example, that sales history graph that I've stored in the database, and then I can ask with this graph query language how many persons are there, how many labels and stuff, and I can go here, for example, and see who knows persons above drinking age. Basically, select the names of two persons where one knows the other, and the one that's known is older than 21. That's apparently American law, right? Here, this would be 18. And then when we run that, this notebook gives us this very nice graphical presentation and everything. And then I can have this graph, and I can click on it and see those persons and stuff. So the graph functionality plus those notebooks and all this ability to use it in the cloud, that's coming with the autonomous data warehouse for the price that it has, right? And that is not something that Snowflake does currently. Basically, I mean, Snowflakes, I'm going to go share back now to the presentation. What Snowflake does, I mean, they of course they had to start small, and now they have to catch up, right? So basically what they are doing is they're focusing on the core, and they try to do all the other stuff with partners. So they have partners for machine learning, they have partners for this, they have partners for that. And that's okay, but then you don't have that seamless integration that you get with the autonomous data warehouse. It all comes back to the old best of breed versus a converged integrated setting wars that we had for decades already, right? So finally, I'm coming to the end. It's the pre-last slide, Edel. Is that okay? Do you see it?
Yes.
Okay.
Yeah.
So last words to ease of use. We have all this tooling in the autonomous data warehouse with notebooks and this and that, and we have Application Express for application development, and of course OAC is directly integrated, more or less directly integrated, but very easy to connect. Snowflake is not providing that. They have this SQL browser interface and a great engine with the functionality that we've been talking about. But if you want to do other stuff like machine learning, graph, and whatsoever, you need additional tools. Of course, you may like that, you may not. Depends on your personal and your company strategy. Okay? So finally, the comparison, I'm going over that. I'd say autonomous is more mature and has more capabilities than Snowflake. But yeah, if you have an Azure strategy and you can't use ADW, then okay, let's go to the conclusions. So what did I say? Analytics require massive scan and aggregation performance. Today, we want functionality beyond pure SQL and structured data. We want graph and ML and this and that. And ADW provides all of that. So if you need all of that and you can go to the Oracle Cloud, ADW is the way to go. Snowflake is great in its scan performance and stuff. You might have to use some credits for it, of course, but also ADW is not for free, right? If you want to or need this tuning and metadata modeling capabilities and features, then Oracle is basically superior still. But Snowflake, of course, has this data sharing feature, which might give you very interesting use cases. Especially with the marketplace, you might be able to monetize that. And of course, it's multi-cloud available. So you have at least the feeling that you're not locked in as much into a platform as with the ADW. So Snowflake is the choice for users not using the Oracle Cloud as of now. If you can use OCI, I would go for ADW if I'd have those diverse workloads and requirements. So conclusion is both are great. Choose what fits your needs. I hope I was able to help you a little to shine a light on what their capabilities are. And yeah, with that, I've finished at the end of the talk. So and Edel, giving back to you.
Thank you so much, Holger. It was very, very interesting. It was really, really interesting. And in fact, it's I saw some presentation from you in the past about the similar topic. Mm-hmm. And I saw that there's new updates on both tools, and thank you so much for this. It was very, very interesting, and with demos, even better. Thank you so much. And before leaving, there are a few questions that I will send you by email, so you can answer them. Okay. But before